Hello, everyone. Welcome to the first keynote of the last day of SINFO. Please join me in welcoming Melda Salhab from Uber.
All right, can everyone hear me? Okay, before I start, I'm going to give a quick intro. Like was said, I'm at Uber. I'm a technical program manager in the Uber AI team. When I started my career, kind of back when, kind of at your age, I actually started in economics, and I worked in public sector consulting at Deloitte for a few years. And then AI started becoming a thing, and data science, like blockchain. I'm like, okay, this is really cool. How can I pivot my career and get into that? So that's when I quit consulting, did a master's in data science, and then did a PhD in spatial data science. I'm going to touch a little bit upon the work that I did. And then I got into Uber, initially as a data science, and now more in kind of the management strategy part of the work that we do. So today, I'm going to talk about how to lie with AI. And that does not mean I'm actually going to teach people how to lie with AI. Let that be a disclaimer for this talk. But more of how AI can lie to you, how bias ends up in AI algorithms, what we can do about it, etc. So to kick off, show of hands, who here feels like they can understand AI? All right, seeing a couple, maybe about like 10% of people. So for the rest, you are not alone. Even the scientists who built AI, I'm going to move this for a second, don't know how it works. And that's quite common, and we're going to get into why that's the case in a little bit. Another question for the crowd again. Do you feel like you understand AI well enough to spot a lie? So if you're typing into ChatGPT, do you know when it's lying to you? Show of hands. Okay, I think it's the exact same people. So let's test you out. So this was a tweet, or I don't know what it's called now in the world of X, but a post, I guess, on X. Back in 2023, when Google launched its first kind of chatbot type thing called Bard. So it was the precursor to Gemini. So in its launch kind of campaign and the ad that it put this example on how you can use Bard at the time. It just wrote, what new discoveries from the James Webb Telescope can I tell my 9-year-old about? And then Bard gave an answer, and this was like, recorded and made into GIF, whatever, and Google went live with it. Anyone see anything wrong with this post? Looks pretty good, right? I mean, obviously, comms must have approved it, went through all these sorts of reviews. However, this point was incorrect. It was a lie. And thank you to the world of the internet who spotted this almost immediately. The first photo of the James Webb Telescope was taken 16 years before here, so this was incorrect information. You say this is not a big deal, but this was a big deal. Google's stock dropped, and they lost $100 billion in value in a single day just because of this. And I mean, I don't work at Google, so I don't really know, but I would say it's one of the reasons now their chatbot is called Gemini. It was a completely new rebrand, relaunch, etc. So it is very difficult to spot lies, because that looks like very authoritative content. So let's get into why that happens. So question, what is AI? We throw this around, we talk about artificial intelligence, it sounds really cool, but what is it actually? So let's get into it a little bit. This is going to be a bit, instructor-led, but I think it's important to understand some fundamentals before getting into the bias and how these things go wrong. So in a traditional algorithm, you write the rule, A plus B equals C, that's your model, and you give it the input and it gives you the output. Pretty straightforward. In machine learning, you give the input and you give the output, and then you ask the machine learning model to figure out the pattern. So that way, when you give it new input, it kind of figures out the pattern and it provides output. Pretty straightforward. This is super, super simplistic, but it's kind of the foundations for how a lot of machine learning algorithms work. But what if you give it a different input, and then all of a sudden you got a different output? Why is this the case? So in this particular example, the machine learning algorithm found a different pattern to get the same results. And all the data it had seen so far that we trained it on, the pattern it found was that A times 2 equals C. B was actually useless information. It found a more efficient way of getting the answer that we wanted and everything we trained it on. But what the pattern we wanted it to realize was different, so we got incorrect information. This is also a very, very simplistic example, but goes to why sometimes AI makes mistakes, in that what it's trained on is not necessarily what ends up being exposed to when you deploy it out into the real world. So when we think about machine learning, we think about there's actually a massive range. This is just a few examples of the type of machine learnings. It can go from something as simple as a linear regression, which I'm sure a bunch of you have studied in your statistics classes and university and high school, all the way to neural networks, which are kind of the more cool things that have powered a lot of the really cool innovation that we've seen. The joke in the data science world is that statistics got the glow up of the 21st century. First one called machine learning, that wasn't that cool, called artificial intelligence, and all of a sudden it's on the news, and that's why everyone likes it. But to go back into actually what is machine learning, so this is kind of a conceptual representation. Generally, when we start with like classification, linear regressions, things like that, you can actually get decent model accuracy, but for simple problems. When you get into more complicated things, you have to go to the more complex types of machine learning out there, like deep neural networks, for example. But there tends to be a trade-off that when you're looking for higher accuracy models, you lose some explainability. It's hard to understand how exactly this model is working, what features are leading to what output. And that's kind of where complexities started emerging. So why do we use things like deep neural networks? Because you can't use a linear regression for something like this. When we're trying to figure out, is this person the person on their ID? Or if we're trying to figure out how to read the text from a receipt, for example, that's where you need the more advanced types of machine learning. At Uber, we've used machine learning probably since our conception, and we use it everywhere. This is just a handful of examples that you probably interact with whenever you use the app. So it goes from when you're logging in, the security authentication, so we know that you are indeed you and you're not a scammer, a bot, etc. When you're searching, so when you search like a location, maybe SINFO or university, the autocomplete, that's AI. When you get this result ranking of what we think you're searching for, that's machine learning. When we're doing all sorts of ETAs, so estimated time of arrival from the driver to you, or to you to your destination, and then the pricing algorithm, all those are different forms of machine learning AI. Product personalization, like probably I use a specific product, so that will pop up more often. Maybe other people have different preferences, so that ranking of trips is different based on each person. So that's machine learning. On the actual trip, there's a whole bunch of safety features to make sure that things are going right on your ride. That's machine learning. And then finally, even when you go to payments at the end, payment fraud detection, making sure that all sorts of things with payments that could go wrong don't go wrong. We also use machine learning there, as well as customer support. And really, it's just a handful of examples. There's so much machine learning that powers, I would say Uber, but also almost every tech tool that you use out there. So to go back to the kind of more advanced types of machine learning. So I don't know if anyone's ridden like a Tesla and you've seen the screen on the front, and sometimes it's automatically like detecting the car and the person on the bike and these different speech signs. So this is super, super useful. So in our world, like in Uber, we really care about having accurate maps. We want fresh map data. So machine learning would be extremely useful for us to figure out where there's a stop sign, where you can turn right, where you can't, etc. But then how does that actually work? So this is kind of a cool artistic interpretation that I found online of how neural networks or machine learning sees, like quote unquote. So very different to how us humans see things out there. So it's actually, every image is in fact, like if you look at the image on your phone, tends to be, it's just a grid of numbers of red, green, blue in each cell, and put together that ends up being an image. So we look at it as colors, but the machine learning algorithm looks at it as numbers. And it figures out patterns to say, okay, that's a car, or that's a stop sign, etc. I also found this other cool example, which is showing different layers of a neural network, which is kind of more advanced, like when it's figuring out more advanced patterns. I don't know if you can see it, but it's kind of showing how machine learning is seeing all of these different things. I think there's a pirate ship, a rocking chair, and a teddy bear, a tie, a picture. Then in each level, it looks very abstract here, but then you can kind of see patterns emerging, because that's really all it is. It's looking for patterns and to see, does the thing match the pattern that it knows. So that also means this is why this image can easily trip up a machine learning algorithm. Are we looking at a chihuahua? Are we looking at a muffin? I mean, even me, like, I have to look at this for a little while to get it. But, you know, if we spend a minute on this, we know that this is not a chihuahua. Like, I think we'll be able to get there. But I think, you know, now based on what you know of how machine learning looks at things, you can see how that can be a very, very difficult thing for machine learning to do. So imagine like self-driving cars. Like, we need this to be super, super, super accurate. All right, so how can machine learning go wrong? And this is kind of the crux of this conversation. I'm going to go through a few examples, like real live examples of things that are out there, and we'll see how it worked and how it didn't work. So this was a machine learning model that was used called Compass software. It's used in the US, in some states in the US system, to see that what is the risk of the person who has been arrested of committing that crime again. Because that's usually how judges determine you're going to get like a month jail sentence or like 10 years or something based on how, like, what's your risk of committing a crime again. So here are two different examples. 2 people were arrested for petty theft, and over there, 2 people were arrested for shoplifting. So person A, in both cases, have a longer like rap sheet. They have a criminal record, which, you know, we would say is probably not great. 2 armed robberies, attempted armed robbery. Over there is domestic violence, grand theft, like the games we were playing outside, you know, drug trafficking, etc. And then person B have very minor rap sheets. Like there was, I think, petty theft and juvenile misdemeanors. Anyone guess which, is it person A or person B who's more likely to commit crime again? You're saying A? I think everyone says A, right? Well, what did the algorithm predict? In both cases, it predicted that person B had a much higher risk score than person A. And I'm going to cut to the chase here. Unfortunately, the only distinguishing factor in these 2 cases was race. So we're going to get into why this happens. And this was actually a software that was used. And it was only until these researchers started using the data to see, wow, this is predicting highly biased results, ended up being a whole public scandal. But I think it is actually still used in some states, but has been modified quite a bit. I'm going to find another example. And this is something you can try on your phones, on your laptops next time you open Google Translate. So I've done this a few times over the years because I first saw this discrepancy like about 6 years ago. If you write a piece of text and use gendered pronouns, like she is a journalist, she is a leader, he is exhausted, she works, he has a headache, she has a great car, he is taking care of the child, she takes care of things. And then translate it to Finnish. Why Finnish? I don't speak Finnish. But Finnish has gender-neutral pronouns. So they don't have he or she. It's kind of the same pronoun for both genders. And then translate it back to English or to whatever language. So in this case, actually, Google got it better than it was before. But now all the she's are basically he, except one, which is she takes care of the child. So everything that we had before, now it's he is the leader, no longer she is the leader. I've tried this again, and it's interesting how each time it gets different. But this is something you could say is so trivial, right? Like Google Translate. I use it all the time. I live in the Netherlands. I don't speak Dutch yet. I'm using Google Translate to read the ingredients when I go shopping. But even this model has gender bias in it. All right, let's go to one other more recent example. There's a new kind of chatbot out there, or like AI tool from Stable Diffusion. It creates images. It's really, really powerful at creating like photorealistic images. So this research team at Bloomberg, they did a really interesting study where they would write a phrase, like I think it was like 100 times, and they'd see what image the AI was creating. So we have the animation here. So you write a color photograph of an architect, they do it 100 times. A color photograph of a cashier, and they would do it also 100 times. And each time they were measuring the skin tone and the gender of the people. So color photograph of a CEO, and so on and so forth. So I have one, a dishwasher. And then they took all of these results, and then they, do I have any more? Doctor, yeah. All right. and they, recorded the results, put it in a way that you can interpret it. It was really, really interesting. Two big results. So first, as I think was evident before, things like CEO was white male. That was the majority of the cases. Things like cashier, housekeepers were majority women and women of color. But what was even concerning is you could say, okay, well, that's kind of the reality, right? Like CEOs are mostly men. But here they compared it to actual data. So the actual accurate, what are the proportion of doctors who are women? So in the US, at least in 2022, 39% of doctors were female, but in the results it was only 7%. Similarly, for dishwasher, cashier, etc., it was generating more women than is accurate. So not only is it promoting biases, it's actually almost undoing the generations of work that we've done as a society to become more inclusive, diverse, etc. It's showing a more biased picture than reality, which is really unfortunate. All right, so why does this happen, right? Like, I don't think anyone who's working in AI is like, I want to make a biased algorithm. I really doubt that's the case. Most people, I genuinely believe, have the best intentions and don't want this to happen. And I also believe that they're trying their best to make it not happen. Like, how can we prevent this from happening? No one wants their AI model to be in a Bloomberg article. That's not good for stock prices and for other reasons. So why does that happen? Anyone here in like finance or accounting? Anyone heard of FIFO, LIFO? Basically first in, first out, last in, last out. It's a thing that's used. So in data science and AI, we say garbage in, garbage out. So if your data is biased, then your output data is going to be biased. It doesn't matter if you're using the most advanced neural network powered on like 1,000 NVIDIA chips, you will get shit outputs if you have bad data. So let's go into how this actually happens, because also no one wants to use bad data. I think people know better than that. But it is very, very, very difficult to get that perfect data set that you want. So first, historical bias. Our history is not great. Our Earth, the societies that created before us do not have there's a lot of bias there, gender bias, racial bias, so on and so forth, disability bias. We don't have a good data set to start with. And then you're selecting data, so that goes into representation bias. You as the researcher or the AI person is going to say, okay, I have all this data, I'm going to select the data that I can, and that's representation bias. It could be you have some views, intentional or not. It could be you have access to some data, you don't have access to other data because of licensing. Whatever it is, but you're not actually getting a proper representation. And then measurement bias. So you have all this data. So let's say I'm interviewing everyone in this room. You have been selected for a study. What questions am I asking you? That is me measuring the sample size. There's bias in me making that decision. And then it goes on to evaluation bias, aggregation bias. Am I going to aggregate based on gender? Am I going to aggregate based on age? Am I going to aggregate based on this half of the room and this half of the room? Like, who knows? We do have to aggregate, but this bias will be introduced. So all of these there's bias coming into pretty much every decision or every point in this process. Then the typical kind of machine learning journey, if you're a scientist or even if you're just kind of a user of these things. So machine learning is really the tip of the iceberg. Like, that's what people want to do, the really kind of sexy stuff. But there's so much underneath that goes into how to create a proper algorithm. Biased or unbiased, this is the work that you need to do. You need to collect the data, you need to clean it up, you do some exploratory data analysis to see how good it looks like, choose a model. Like, are you going to use the new OpenAI o1? Are you going to use Meta's Llama? What are you going to use? You have to prepare it, set your parameters, train the model, evaluate the model, tune your parameters, and then you deploy it. There's so many steps that go into it. And this is actually extremely simplistic. I'm like simplifying years' worth of work into one side. But all of these are human decisions. So if I am doing this project, that will be very different than pretty much anyone here doing it, because we're all making decisions based on the knowledge that we know. So I'm going to give you one example of like a low impact a project I did for my master's thesis, just to show you how many decisions you have to make. So what I was trying to do was, I'm Lebanese, so I wanted to do a land cover map of Lebanon to see how urbanization, like how land cover changed over time. Are we losing our forests? Are we like, how quickly are our urban areas growing? Are we losing water? So I'm like, okay, I want to do this for 20 years of of history using a ton of satellite imagery. And I'm like, okay, there are two ways that we can do this using machine learning. I need a training data set, right? So I need to say that this particular pixel is forest and this pixel is like barren land. So I did my own data set. I'm not even kidding, on Google Maps. I started putting points. Like, this is what I can observe. Like, that's built up area. This is water. This is non-forest vegetation and crop. And then I also sampled a very coarse resolution data set that's produced by the European Space Agency. So I'm like, okay, let me try both of these data sets. So that's me choosing the data. And there's obviously bias, even in that decision process. And then I'm like, okay, so in terms of satellite imagery, so remember how we talked about red, green, blue? Satellite imagery has a lot more than just RGB. There's like ultraviolet, there's like a whole bunch of spectrum that is not visual to the human eye, but the image collects it. I'm like, okay, well, that can be pretty good. Like, near infrared is really good at vegetation. So like, what do I use? Do I just use them all? Are they gonna be like internally correlated? Will that mess up my results? I don't know. Like, what do I do about clouds? Like, random, but that's really important. Like, the presence of clouds, which are more in winter days and summer days, is messing up my results. Do I delete them? Do I put multiple images together? I don't know. What models should I use? Those are all questions that I had to answer. So what you'd usually do if you're doing any sort of research, you see what have other people done before. So that's kind of what I did. I'm like, what have people done? And I found the best way to make the decisions. But also that is biased. Just because people have done that one particular process doesn't mean that's the best way of doing it. So what I ended up doing is I tried a ton of combinations. This is the power, the computational power that has made statistics into data science. So I'm like, okay, let me try using bands 2 to 7, and then add 10, and then add index that I calculated on vegetation, then add elevation and slope, which now I know would be very relevant to Lisbon because there's a lot of elevation and slope here. And then I looked at different models, so I'm like random forest, carts, support vector machine. So I just ran it across all these combinations and across the two data sets until I found the ones that had the highest accuracy and coefficient results. But even then, these were me making decisions. Low impact project, because like it's just my, my thesis, which I'm very proud of, but it's not actually going into, a consumer-facing thing. But these were all decisions that I made. So let's go into something a bit more recent. So if we talk about like ChatGPT or LLMs out there, so how does this work, right? It's very different because you're training a model on an enormous amount of text data. So who's doing these decisions? How do we make it better? What's the testing, the training? How does that look like? So a big thing I want to highlight here is this term reinforcement learning. Anyone heard reinforcement learning before? All right, I'm seeing some hands, some nods. So anytime you see like a really cool title, probably something less cool underneath, and we're going to go into like what reinforcement learning is. And this is what OpenAI and pretty much every LLM foundational model owner, I guess, is trying to do, is use reinforcement learning to get human feedback, which improves the models based on feedback of the users. So what does this process look like? Gonna break through, go into it step by step. So if you were hired to be a reinforcement learner, and this is a job you can actually do online and make a few bucks like an hour, you ask the trainer, which would be you prompt ChatGPT or the chatbot something. What is the best tech conference in Lisbon for students? And then the chatbot provides two responses, A and B. And then usually you're given some sort of instructions. So choose the best answer based on honesty, it could be on helpfulness, could be personal taste. So the trainer picks the best response. Obviously, there's trainer bias here. But a really important thing to note here is that you have to choose an answer even if they're both wrong. Even if the chatbot is providing something that is actually factually incorrect, you still need to choose an answer because the way it works, it kind of ranks answers to ultimately get to the right thing once you have a big volume of data. But what this kind of actually means in the bigger picture is that it's easier to make a chatbot sound human than it is to make it accurate. So chatbots sound so human because they're trained on vast amount of human-generated data. The responses are ranked by humans. Both of the above obviously have biases and inaccuracies. And there is no unambiguous truth to test against. You cannot say, here, just use this like encyclopedia, like used to be, this is the truth. There are many different opinions out there on the world of the internet on, what is the best tech conference in Europe, let's say. So it's very difficult to say this is the truth and we're going to test against that. So as I said, it is much easier to make chatbots sound human than it is to be accurate. I'm going to start wrapping up. So what next? Okay, we know all of this. I'm happy to discuss a lot more in detail. So as a user, be vigilant of bias and inaccuracies. Please do fact check when possible. I think this is a muscle we all need to learn as a society. Fact check when you can. Be careful when you deploy or use AI. We're using AI everywhere, and I think we absolutely should. There's I use it all the time. If I need to write my own bio for this conference, I'm like, this is who I am. Like, give me 100 words on, a bio that I can use. Like, it is extremely, extremely useful. Be part of the conversation. I think generally we tend to be intimidated to have opinions and to be part of conversations on things we don't understand fully. I disagree with that. I think we absolutely need to be part of the conversation because AI is impacting us whether we like it or not. So, being vigilant, being there is important. Be open to all the good impact AI is having. I can tell even at work, we have a ton of software engineers. We all have different expertise, etc. But also people from different countries. Something I've personally realized is now that we have access to certain tool, it's kind of leveled the playing field for skills that are harder to do. Let's say, English proficiency. We have to write all these documentations on stuff, but now we can just go into a chatbot and say, this is what I need it to do, or we get Gemini to review our documents, just making it a lot easier to get over these hurdles, which, are just really difficult to do otherwise. So, this is just a silly example, but there's so much good impact AI is having. So if you are someone who's working in AI, I'd say invest in responsible AI programs. And we're going to talk a little bit more about this to tell you more about what Uber is doing specifically. So I'm one of the leads in the Uber Responsible AI program. We have a bunch of different work streams: governance, transparency, explainability, education. Even that, I think, is just a start. There's so much to do. So on the governance side, we have a lot more rules now. If you're using machine learning, we need to know what you're using the machine learning for. What's the impact? Are it going to touch users? All sorts of information. If there are certain things that are risky, legal needs to know about it and go through a review process where we can say, no, you're not allowed to do this. Transparency, this is one of the things that I'm personally leading. We want to know everyone using machine learning. It's a very difficult thing to do. Right now, if your university wants to know who is using ChatGPT, is there a good way of knowing that? And for what use cases you're using it for. It's actually very, very difficult to monitor everything that's happening. And that's something we're putting a lot of work into and having an easy way for us to figure that out. Explainability, so we want to know to the largest extent possible how the models are working, so what features are being used to create the output. We need to understand the models that we're using. And also part of that, we're creating something called a fairness estimator. So we'll take a model and then using different data, see how is it predicting different outputs for males versus female, for different races, for different cities, different countries, etc. So that's a big thing we're investing in. Education is huge. It's kind of one of the times in history where we have access to such powerful tools, on your phone. There's no barrier to entry. So now we've invested a ton in education for anyone in the company, but also for people who are using it, the bar is even higher. So highly, highly recommend that every company does that. Explore the work being done on fairness testing. Just because AI is difficult to check fairness of doesn't mean it's impossible. So there's really interesting research happening. And then finally, I think it's really important to hire diverse teams. So if there were, different genders, different nationalities, etc., working on these products, that just brings in more voices in the conversation, makes all those human decisions that we spoke about before to at least have various perspectives. I'm a big fan. I was saying yesterday at dinner that I like to not make a decision until people disagree. We need to have disagreements. We need to have different points of views before we say, yes, this is what we want to go with. So diversity of opinion is super important. With that, I'm going to end, and I'm going to be around for questions here and then questions outside as well. So happy to answer here or there. Thank you.
All right, so thank you so much, first of all. It
Thank
was
you.
so insightful. Does anyone have questions?
Thanks for the talk. I just want to ask, so like Uber, like any company would want to use any technology to maximize profits, right? I don't know about Uber, but many companies would
Yeah.
want to use AI, and a lot of the times they want to use AI to like reduce developer load and like to automate simple tasks, right? Do you think fact checking might not be directly relevant to that for automations, but if can you use like the AI that helps you increase your profitability
Yeah.
without you caring it's biased or not, or is it always good to be? Do you want the truth, the AI to tell the truth, and then you would decide to whether like it's a good business decision or not?
That's a good question. I think there's a lot of nuance there because it really depends what it's being used for. So if you're using, I don't know, there's all these like now plugins on like GitHub Copilot and things like that to make you to like autocomplete your sentence when you're coding. That could be kind of a lower risk thing. I still don't think it should be automatically done. We still need to make sure there's no risk of bias there. But there are kind of categories. That's one thing. Versus if we're using AI to work on our like background check program, like that is very high risk. So absolutely needs a ton more checks and balances before we get there. So it really kind of there's a scale. I think there's no company that is not exploring the use of AI, but there are guardrails you can put in place to make sure that you're optimizing productivity, you're letting people use this tool, which if you don't let them, they're still going to do it, but they're going to do it outside, in places that are less safe. So you can allow them to do it within the company servers, all of these things, but in a safer way, and still making sure to kind of block the use cases that you don't want. And also a huge, huge part of this is education. So just now, I would hope that at least you've learned a little bit more how to be vigilant in different places. So if every user of AI has that information, you can at least start to detect, okay, this is output that I don't want, or maybe I should double check this output. Maybe this is not, in fact, the best way to do it. So it's very much like a balance game. And I would say, okay, obviously companies do care about productivity and profitability, but that's not the end game. Like if that's all we care about, there are a million shortcuts to get there with AI or without AI. Like it really has to be a holistic approach.
Does anyone have any more questions?
Thank you for the talk, madam.
Thank you.
Just to start, it was a very good talk.
Thanks.
And from the beginning, when you talked about the translation, the Google Translator,
Yeah.
would you say like training models in languages like Finnish, like translating the data to a language that doesn't have the gender bias, for example, would help in mitigating the bias of the model itself?
I think that's a really interesting question. I think that's like a thesis right there, ready to go if anyone's looking for a thesis topic. It could. I think that's a really interesting way. Like if you can get rid of the bias in your input data, theoretically it would reduce the bias in the output data, but there's also like inferred gender. Like pronouns are not the only way to get it. It can be from like, mother, father, from like other sister, brother, things like that. But I think that's a really interesting research topic. So, for you, for anyone else who wants to look at this.
We have, okay, one last.
Hi, Melda.
Hi.
Thank you for the great talk. I would like to ask about lying. Humans lie all the time. And I would like to know, in the race for artificial intelligence trying to reach human intelligence, should we accept that AI is becoming more human-like by lying? And also when there exists white lies and lies that benefit the human instead of being realistic. What is your point on that? And do you believe that we should try to fully mitigate the lies, or should we put this into consideration?
Also a very good question. I think it depends like what we're striving for. Like, and you know, it's a diverse opinion world out there. Like another group of researchers who are absolutely obsessed with artificial general intelligence. Like we need to create human-like, you know, bots. Other people are more interested in kind of you can use machine learning / AI in highly productive ways that don't need to be human-like. Like, I mean, we use, I'm sure, calculators, Excel spreadsheets. Like, no human is an Excel spreadsheet, yet we've found a way to use that to increase our productivity. So I think there's so much benefit in optimizing for the thing that we want to optimize for. And I'm not sure if optimizing for being human is always necessarily the right thing. I think it's very interesting to watch the work of like Sam Altman and everyone obsessed with like, can we get to human level? But then even when you're talking about human, actually a good analogy to this could be self-driving cars. Because we're kind of at that phase, right? That we're trying to create cars that can drive equal or better to humans. So for a question like that, now it's a big topic of discussion. Are you willing, if humans on average have one car accident in their lifetime, are we willing to accept that threshold for self-driving cars? I would say probably most people would say no, the threshold should be much higher. Self-driving cars should be much better than humans. Like we're not trying to just replace a human driver, we'd only want to do it in cases where we're absolutely convinced it would be better, because otherwise, what's the point? So my opinion would be like the threshold for lying, things like that, should be unambiguous. It should be as strict as possible, because also the like as a user, like if I'm talking to a human, I could kind of know if someone has an ulterior motive, you know, for competing for something. There's lots of indicators that you can get to, and contextual clues to figure out if that person really knows what they're talking about. Versus AI, it sounds like pretty darn authoritative. Like you know, it's creating text in a beautiful way. You're like, yeah, that sounds like a Wikipedia page or something that has been fact-checked. So I absolutely think that the threshold should be higher. It should not be equal to human, it should be better for things like accuracy and trust.
Thank you so much again. If anyone has any more questions, Melda will be in the second stage to answer them. And now for the pick a winner. Pick the winner. And the winner is Maman Jamri. Sorry, yeah, hi. And thank you again, everyone.